Welcome back to BarnesBasics, and we're going to do problem 1b. It says a mass of 25 grams of mercury 2 oxide is decomposed by heating. The reaction is 2 moles of mercury oxide yield 2 moles of mercury and 1 mole of oxygen. The question is how many moles of oxygen are prepared in this equation. So this is a stoichiometry problem. It's a continuation of the previous video. Number one, in stoichiometry problems, we write the balanced equation. This one's already done for us, so that's beautiful. We see 2 mercuries, 2 mercuries, 2 oxygens, 2 oxygens. Lovely, lovely. The second step is rewrite what is given on the left. So in this case, we're given 25.0 grams of mercury oxide. We're asked to find moles of oxygen. So let's put moles of O2 on the right. So this gets a little bit trickier. So if we're going to go from grams of mercury to moles of something else, this is not a single step reaction. So the first thing that we have to do to convert from grams of mercury to moles of mercury is to look at the formula weight. And we've already determined that the formula weight of mercury oxide is 216.58 grams per mole. We looked on the periodic chart. We only have one atom of mercury. It weighs 200.59 per mole, and we have 1 mole of oxygen, or one atom in this little formula. 1 times 1599.99, we get 216.58 grams per mole. So we would say that 1 mole of mercury oxide is the same thing as 216.58 grams of mercury oxide. And so the next thing that we have to do in this formula is figure out, since we've gotten rid of grams so far, we've got to go from moles of mercury oxide to moles of oxygen. So since we're trying to get moles of oxygen on the top, we have to put moles of oxygen on the top in this little ratio here. When we look at oxygen in the formula, it's understood that there's a 1 in front of here, so we say that in this balanced formula, to get 1 mole of oxygen, we have to break down 2 moles of mercury oxide. So we put 2 moles of mercury oxide on the bottom. This cancels, this cancels. The only unit we have left is moles of oxygen, which is what we're trying to get. And now all we have to do is just crunch the numbers. So pay attention closely here. I'm going to be running this on a TI-83. I want you to multiply everything on the top, then divide by the first thing on the bottom, enter. Divide by the second thing on the bottom, enter. That's roughly what I want you to do. So on, clear, clear, clear. 25.0 multiplied by 1, hit enter. You should get 25. Divided by 216.58. Enter. I got 0.1154. That's perfect because that's what I got in the previous video. And then divide by 2 and hit enter. And we get something like 0.0577 moles of oxygen. Now let's talk about this. Remember that in sig figs, leading zeros are not significant, so only these numbers are significant. The original number 25.0 has 3 sig figs. It has 2 non-zero digits and a 0 trailing behind a decimal to the right of a non-zero digit. So we're going to cut this off right here, and we're going to report the answer as 0.577 moles of oxygen as the answer. How many moles of oxygen are prepared? 0.0577 moles of oxygen. Very good. Marvelous.